Hi, I'm Mike Stanzik, and this is Digital Electronics Classroom. You may be trying to convert binary to decimal, but you're having some difficulty with the method. And so therefore you need a little bit of help, and I'm here to help you, to take you through that a problem example and give you the skills that you need to solve not only this problem, but any problem where you need to convert binary into decimal. So let's take a look at an example here on the screen. What we're going to be doing is converting binary numbers to decimal numbers. Now, if you haven't watched my video on decimal polynomials, it'd be a good idea to watch that now so you can get some background on what I'm going to talk about at this moment. So a binary number is what we call base 2. And so it's going to be made up of powers that have the base 2, like 2 to the 0, 2 to the 1, and 2 to the 2. It also means that it has two coefficients, 0 and 1. So these are the coefficients. These are a very special set of coefficients because 0 means it's not there. So if you have a coefficient of 0, 0 times anything is going to be 0. And 1 times anything is just itself. And so this is going to be really nice for making our numbers. So let's look at an example number. And so if we had the number 1, 0, 1, 1, let's do that. And then a dot here. Now you might think that's a decimal point, but since we're dealing with binary here, that's actually called a binary point. Very exciting. So we have a binary point, and then from that binary point, going leftwards, we have a 1, a 1, a 0, and a 1. Now this is important because this allows us to establish place value. And so there are 4 places here for the digits to go, and each of them has a certain value associated with them that's based on their powers. And so here, this is based on the power of 2 to the 0. And so that is the 1's place, just like it is in decimal. And notice that we can count either a 0 here or a 1. So it's going to be either 1 is not there or 1 is there. And so a 1 is there, 1 can be shown here, but a 2 can't be shown here. And so we have to have a spot to put 2's. And so this is going to be our 2's place. And you can also see that this is the power of 2 to the 1. And so this is going to be our 2's place right here. And so I can count 0 2's or 1 2, but I can't count 2 2's or 4. So to count 4, I need another spot to count 4. And that's going to be the next one. And so that's going to be 2 to the power of 2, which is going to be the 4's place. And so you notice that this doubles each time. It increases by a factor of 2, and that's where the powers of 2 comes in. So 2 to the 0 multiplied by 2 is 2 to the 1, multiplied by 2 is 2 to the 2, then 2 to the 3, then 2 to the 4, and so on and so forth. So this is 2 to the 3rd power, or 2 times 2 times 2, which is equal to 8. So that's our 8's place. Okay, so we have our 1's place, our 2's place, our 4's place, and our 8's place, 16, 32, 64, 128, 256, as we go on and on. And also if we go beyond the binary point in the rightward direction, we get powers that are negative, 2 to the negative 1, or the halves place, and 2 to the negative 2, or the quarters place, and so on and so forth. But that's a little more advanced. We're not really thinking about that right now, and really doesn't have a lot of role in basics of the computer number tracking. So let's go ahead and write this out as a polynomial. And so to take these, we write them with their coefficients. And so in this case, I have 1 times 2 to the 3. So our number here, which is 1, 0, 1, 1, base 2, is going to be 1 times 2 to the 3 plus 0 times 2 to the 2 plus 1 times 2 to the 1 plus 1 times 2 to the 0. And so this is 1 times 8 plus 0 times 4 plus 1 times 2 plus 1 times 1. And so this is going to be equal to 8 plus 2 plus 1, or 11. And that 11 is a decimal number, so it gets base 10. And that's how we do it for any number that is binary converting to decimal. Thanks a lot for watching.